Hello, everyone, and welcome to our latest critical conversation. My name is Hayaatun Sillem, and I'm the CEO at the Royal Academy of Engineering and the Queen Elizabeth Prize for Engineering Foundation. And it's my great pleasure to be hosting another of these online fireside chats that we run to explore topical issues that are important for engineering and for society. Our overarching goal at the Royal Academy of Engineering is to harness the power of engineering to build a sustainable society and an inclusive economy that works for everyone. And we've used these critical conversations to look at some of the engineering challenges and opportunities that will be crucial to addressing this goal. In March 2023, the government published its UK Science and Technology Framework, which set out the 5 technologies that are most critical to the UK: quantum technologies, semiconductors, engineering biology, artificial intelligence, and future telecoms. And we've been exploring each of these technologies through this mini-series of critical conversations. For each event, I've been joined by an array of brilliant experts to help us to understand what these technologies are, to navigate why they matter, and what we need to do to capture the benefits and manage the risks. Our first event exploring quantum took place at the end of July. We then explored semiconductors at the beginning of September, and engineering biology at the end of September. And if you missed those, you can still catch up via the link that should be popped in the chat. So today we're going to be focusing on future telecommunications. Simply put, telecoms refers to the exchange of information, voice, data, video, over significant distances by electronic means. And I know this might be stating the obvious, but we are, of course, using telecoms right now. When we talk about future telecoms, we're thinking about the deployment of 5G, 6G, and beyond. Future wireless technologies promise huge benefits for businesses and users, as wireless connectivity is, of course, a crucial utility for any modern digital society. And the development of advanced telecom capabilities will also influence broader technology development, including in areas such as AI, which we may come on to later. So, to help us learn more about this fascinating topic, I'm delighted to be joined from California by Dr. Tatipamula, Academy Fellow and Chief Technology Officer at Ericsson, Professor Dimitra Simeonidou, Academy Fellow and Professor of High Performance Networks at the University of Bristol, and Dr. David Parker, Academy Fellow and the co-founder and former CEO of Luminicity, world leaders in hollow core fiber, which in December last year was acquired by Microsoft, where David is part of the leadership team for Azure Fiber. Welcome to all of you. Thank you for joining us. I'm going to just give a little bit of context before we get going properly. So the evolution of telecommunications has played a really fundamental role in connecting the world. From the invention of the telephone to the rise of mobile communication and the internet, each milestone has brought people closer together. The impact of telecommunications on economic development is immense. It's opened up new avenues for businesses to expand internationally, connect with customers worldwide, and explore global markets. And the ease of communication provided by telecommunications has enabled transactions to be conducted instantaneously, increasing the efficiency of trade and commerce. With the emergence of enhanced connectivity, along with 5G and technologies such as 6G, AI, and cloud computing and storage, the future of telecommunications is poised to transform a whole range of industries, from financial services to healthcare, transportation, and manufacturing, as well, of course, of impacting on how we lead our lives. And in tonight's discussion, we're going to discuss the challenges and opportunities that future telecoms could bring. Will we see the same pace and scale over the next decade that we've seen over the past one? And we're also going to take a bit of a national perspective and explore the UK's position in the global community. But that's enough from me. I'm going to turn now to our panelists. So we're going to kick off with a bit of discussion amongst ourselves, and then we're going to open it up to audience questions. You can drop your questions into the chat at any time, and we're going to try and get through as many of those as possible. So we look forward to hearing from you. Brilliant. So I'd like to start with you, Dimitra, please. Can you tell us which aspect of telecommunications you work on and why it matters, especially to the public?
All right. So here at the University of Bristol, Hayaatun, I'm leading a big research center, about 200 academics and researchers working across a number of technologies, from IoT to wireless to optical to cloud, physical infrastructure to cloud services. So you may say that I have a good overview of telecommunications technologies. Now, myself as a researcher, I identify myself as a systems person. So I'm working on networks, network architectures. I'm interested to look end-to-end network performance and performance optimization, driven by enabling technologies, but also at the same time from application requirements. So I'm looking at complexity and heterogeneity and convergence. And if I want to see some application areas that I identify myself with, smart infrastructure, for instance, smart cities, 5G and 6G, the kind of environments that we take a network of networks approach. Now, why this is important for the society and the world? It's because actually connectivity is a utility. It's at the same level of utility, I feel, like water and electricity. So it's not only underpinning everything, but it's driving everything. So digital transformation that we see in our society and businesses is driven by connectivity. So being able actually to design future telecom systems that they are resilient, they are inclusive, they are fair, and they are actually available to all is very important for the future, and that is for society and economy.
Brilliant. Thank you very much, Dimitra. That's great. So I'm going to ask the same question of you, Malik. Tell us which aspect of telecoms you work on and why it matters, especially to the public and wider society.
Certainly, Dr. Hayaatun. Pleasure to be here. I've been in telecoms for over 33 years, since 2G days. Now, myself and my team focus on 5G technology development. How does 5G benefit society? When you look at the 4G, it really brought the higher speeds in terms of megabits per second, and that enabled the mobile broadband, that transformed the way we live, as you nicely put it in your introduction. Now, 5G is going to extend that mobile broadband experience to next level. We call it as enhanced mobile broadband, where it gives that immersive experience to emerging applications such as augmented reality, virtual reality kind of applications. That's the first aspect of 5G benefiting the society, providing that new ways of experience to the users, accessing emerging applications. The second one is that with higher speeds and lower latency, the 5G connectivity can be extended to the industries, because most of the industrial verticals are going through digital transformation. So connectivity is a fundamental thing to drive the digital transformation. So we are working with the industries and extending the 5G connectivity to enable their digital transformations, call it as manufacturing, utilities, smart cities, transportation, you name it. The idea is that how do you leverage the reliable, low latency, and high capacity connection that 5G provides in digitizing the industries. So in essence, it's all about transforming the user experience. It's all about digitizing the industries, having this now ultra reliable, low latency connectivity provided by 5G.
Brilliant. Thank you very much, Malik. And how about you, David? What do you work on and why should we care?
Okay. It's great to come after my two co-presenters here, because everything that's just been said, which is really important, that brings this connectivity to end users through their handsets and the like, all of that actually ends up in a physical network, in a fiber optic network, for example, that actually pulls that in, and which we sometimes call that the core network, and where it gets a lot of aggregation, and the optical technologies that I've always been working on, such as in the optical transponders, for example, and more latterly in fiber optics themselves and the cables and new and novel ways of bringing higher performance to that core network, is really the foundation stone on which the internet is built. And so you can't have the services that are being generated by the end consumer unless you can move that around elsewhere, either within the data centers, or between data centers, or between different parts of the access points associated in the more distributed network. So that's where I come from in terms of all of that optics stuff that nobody ever sees because it's under the ground or in a data center. But without it, nothing else that we're going to talk about today would work.
Well said, David. So I can already see from the introductions you've given us very helpfully that future telecoms is not really one technology at all. It's a broad system of technologies. So let's try and unpick that a bit more for our audience. And David, maybe carrying on with you, what do our audience need to understand about the technologies that comprise future telecoms?
So the first thing to realize that you can think of it either in layers or like a big tree, where there's the trunk and then lots of the stuff that distributes out. But actually a little more technically correct is to think of it in layers. So you have the physical layer, which is what I was alluding to, and that can be wired and wireless. That's all part of the physical infrastructure that makes everything work. And on top of that, you then have the network layer, which manages how that all happens and interconnects. And then we have all of the services. So it's really very much a sort of stacked approach. And there are challenges everywhere. As we go into the next generations, the more services that are created, the more the demand. But actually, it's a little bit symbiotic because I've been in this industry for many decades. You've also seen times where actually the provision of the platforms in whatever layer it is there, which is really about adding capability, has actually been then the catalyst and encouragement for new services. So it's a very much a symbiotic situation between each of those, and each of those will have new challenges as we move forward, and we'll talk about those a little bit later, but that's the broad perspective. I'm sure others have got some more detail.
Thank you, David. That's very helpful, and we like that layered structure. Dimitra, you've talked about that as well. Is there anything you'd like to add to David's introduction?
I do love layers, and I'm so glad, David, that you're doing all this great work in the physical layer, because I'm working in the network and the service layer. I would like to talk about three technologies that usually, they're not the first technologies we talk when we talk about telecoms. The first one is AI. And that is one of the other critical technologies, our other critical technologies. And AI for networks has become very important. And we start calling native AI networks. And this is really embedding intelligence for optimization, for instance, network optimization, or for automation or customization for the end user. So this is the one technology that we see that probably is becoming more and more focused for network engineers. The second one is what we call convergence. So how we can actually converge different networks together, wireless and optical, terrestrial and non-terrestrial networks, for instance, the terrestrial network with satellite domains. The third one is a bit unexpected, how we can converge classical networks with quantum networks, and that is where our other critical technology comes, and their role in communication and networks, which becomes more relevant. And the third technology is also something that emerging for 6G and would go beyond, is what we call joint communications and sensing. So not using only the infrastructure to communicate, but also the infrastructure to sense itself and report how well it's working, but also sense its environment. For instance, provide very high precision location services for robotics and so on. So this is really a very exciting time to be a network engineer and being able to actually get to know and apply new technologies into the sector.
Thank you, Dimitra. Did you want to come very quickly back on that one, David, before I go over to Malik?
Yes, I wanted to let those points Dimitra makes are absolutely spot on. And they have a very profound impact on the technologies that we're going to develop to enable future telecom. So we've seen the growth of services from voice-based technologies through to the beginnings of the wired internet, now to the wireless internet and so on. And in each of those waves, the demands on all of the technologies, whether they be wired or wireless, have gone through real bow waves of need to go to orders of magnitude improvement in performance, whether that be around capacity or latency, or to call it another thing, delay that occurs in the network. Imagine an autonomous vehicle that's running and using these services, and there's a big delay between the decisions it needs to take and the information it wants. That obviously would preclude that being safely used, just to cite but one example. So I think these new services are going to see us having to go to very significant improvements and reinvention of some of the base technologies to enable these fundamental services to be delivered.
Thank you, David. That's a really interesting build. And Malik, I do want to come to you as well. I'd like to hear your thoughts on this, please.
Absolutely. I think both David and Dimitra put it very nicely. Just to extend, what we are seeing is a massive architectural paradigm shift driven by these ultra-low latency mission-critical applications, where we are starting to see the convergence, connectivity, compute, and AI. You can see that the compute that used to reside in central data center that's being distributed towards network edges. And then you have AI training and inferencing happening on top of these network edges. Why are we doing it? When we extend the 5G connectivity to connect the IoT devices, so-called sensors or machines or robots, they are generating massive amount of telemetry data. So how do we monetize the telemetry data to automate or digitize these industries? So that's when you need connect, collect, process, analyze, and act. Connectivity driven by 5G, collect and process, analyze by compute, and then act, analyze and act on the process data by AI. So there's a fundamental convergence of connectivity, compute, and AI is happening, driven by these low latency mission critical applications. And over next decade, we are going to see the kind of innovation in our sector in future telecoms that we have never seen in our lifetime. As Dimitra put it nicely, on the connectivity front, we are moving towards sub-terahertz frequencies, and also we are looking at terrestrial, non-terrestrial integration, and we are looking at joint communications and sensing on the connectivity front. On the compute front, we are moving from classical computing to quantum computing. On the AI front, we are looking at neuromorphic systems. So you can see it's not only convergence happening between connectivity, compute, and AI layers, but those advancements will continue to influence the future telecoms.
Thank you, Malik. Well, I think audience is certainly getting a sense of the excitement and the potential power created by this series of developments and the convergence of those different technological strands. Malik, can I take advantage of the fact that you're sort of looking outside into the UK? What do you think the UK offer is in terms of leadership in future telecoms on that global stage?
I've worked with UK academia for the last 30 years, starting with University of Southampton during optical amplifiers days. Knowing UK system, I think UK has got very unique strengths. Very unique strengths from connectivity perspective. UK has strengths in terms of terrestrial, non-terrestrial integration. You have the terrestrial strength, non-terrestrial strength. And also you have strengths when it comes to computing and AI front. So I think UK has very unique strengths of bringing them together from systems perspective, and realize the future wireless systems, combining the terrestrial, non-terrestrial from connectivity angle, taking the quantum computing expertise that you already have along with AI, and how do we realize that converged systems.
Thank you, Malik. And Dimitra, if I can now turn to you. You're right here in the middle of the UK system. Do you recognise that analysis? Where do you think the UK isn't as strong in terms of the global context?
Well, I recognize what Malik said. I want to add two more things that the UK is strong, and then I go to the non-strong, if I'm allowed. So we have a very strong university sector. Research in our UK universities in telecoms has been long-standing and is excellent. And that has been recognized, I'm not going to repeat, in the wireless infrastructure strategy, the UK government wireless infrastructure strategy published earlier this year. The other thing which the UK has been very strong more recently is on policy and regulation around telecoms. We led, for instance, policy on supply chain, telecom supply chain diversification. And I think we led this internationally. And the second one, we really demonstrated quite significant leadership on opening up shared spectrum for private networks for 5G, for instance. So those are important. Where we are not strong, okay, that's a personal opinion, but we don't have a large vendor. We don't have an Ericsson, we don't have a Nokia. And that is definitely a weakness for the UK telecom ecosystem, because we do not have a strong voice to talk loudly about telecoms and be a big advocate. However, we managed to get actually this strength, this weakness into our strength. And when I see around the UK, I can see very vibrant cluster of SMEs that they're producing telecom technologies, and David's SME, ex-SME, Luminicity is a very good example of that. But the thing is that because we don't, us as university researchers, take this an example, because we don't channel our research to the big vendors, we provide that more opportunity to have that diverse sector of SMEs, technology SMEs around telecoms. Now, another thing that happened recently, because of this strength on policy in particular, we have seen a quite significant inward investment from international vendors, especially Open RAN vendors, establishing actually activity in the UK, and even bigger vendors like Ericsson start establishing R&D labs in the UK. So there is quite a lot that is happening. We are creating a very interesting industrial environment in the sector.
Thank you very much, Dimitra. Well, that sets up nicely then a topic I want to spend a little bit more time on before we open up to audience questions, and that's commercialization and innovation. So, David, I think it's only right that we start with you on this. You've been there at the coalface. What are the challenges and also the strengths when it comes to innovating and commercializing in this broad field of future telecoms within the UK ecosystem?
Okay, thank you. So I'd just like to pick up on the last point about vendors, of course. We did have such a capability in the UK, where there were very large capabilities onshore here in the UK at all levels, both at the subcomponent level and actually at the network equipment level, and that has been that was dissipated away, and that accelerated by the telecom crash in 2000, and where there's a lot of consolidation happened, and a lot of that unfortunately happened off our shores. Okay, I actually see that we've got an opportunity though, and that opportunity comes with the emergence of these new technological challenges of which we've been talking about, and that is to take what I would absolutely concur about the strength of our academic community throughout the UK. Dimitri's team is clearly one of the world leaders, but they're not the only one in this in the UK academic environment. And how do we pull through some of that work, which is truly world class, and pull it through into commercial exploitation? And once we've gone through the early stage exploitation, that often driven by partnerships between universities and SMEs, often driven by university spin-out type cultures and so on, but which I think we are pretty good at actually in this particular technology sector. The question then becomes, how do you scale? And how do we make sure that with the new and emerging technology areas that we have, that we don't repeat those mistakes, if you like, so bringing things to a short to medium scale, right, and not have the ability to take it to large scale within the UK environment. Okay, and in some ways, I see that as the biggest challenge of all. I think we can talk about lots of other smaller challenges about getting science out of universities and going up the early stages of TRLs. But I think it's when we come to the point of saying we want to now be a global player, as opposed to a small niche or a UK-centric technology deliverer, where the challenges arise. And those challenges are about investment levels, They're about how we are structured in terms of the venture capital partners that we have. Can they then go to scale? Do they have the right partners within the financial community to fund that transition here in the UK? And then governmental support for such a transition as we move forward. And I think if we could actually put more focus in that part and almost rely on a pull-through associated to further enhance what we already do well, but that we could go from being very good to being excellent at, which is taking the academic stuff and the new stuff and bringing it to a certain level. If we could create the pull, then I think we could be successful and not necessarily repeat the history of having a very, very vibrant, larger company platform within the UK. Let's try and make sure we re-energize that, utilizing these new technologies that the future telecom arena is surely going to bring.
Thank you very much, David. Very articulate and passionate description of, I think, what is often a common challenge in the UK around this, scaling up of entrepreneurial companies. I want to, before we go to audience questions, talk a little bit about the strategy that we mentioned earlier. But before that, I just want to quickly come back to you, Dimitra, and just check in on another aspect of how innovation happens, which is business university collaboration, and ask for your perspective on how easy and how successful that is to do in the UK.
UK universities in our sector, they work with industry very closely. Telecoms is an applied science, is real engineering. So actually working closely with industry is very important. And there are many years of one-to-one collaborations with industry. There are schemes where actually there are collaborative projects, especially industry supporting academia in UKRI applications and UKRI projects. There are two things that we discover now that we are missing, especially as we came out of European frameworks, and we are not active. Hopefully we are going to be more active as we go forward in the future. But the thing is, we don't have effective schemes that they can fund large university industry collaborations. So I'm leading now a project which is called Reason. It's a large project, about 12 partners, big academia and industry, including big vendors and service providers. This is a very rare example. It's funded by DCIT and not through mainstream funded channels. Very rare example. But what we see with projects like this is that we create collective ecosystem views through this large collaboration in our research. So that is something that is missing in the UK. The second one, working with industry, what is missing, and I agree completely with what David said, we have UKRI that funds quite a lot of our research. We are developing TRL1, TRL2 excellent research outcomes. That step of translation of TRL1 and TRL2 to 3 to 4, so it's ripe for commercialization for somebody to pick it up. We do not have real mechanism that we can fund that translation gap. And that is where a lot of the university research is being lost.
Okay, thank you, Dimitra. So that brings us on to the UK strategy in this area. So obviously I said at the start that future telecoms has been identified by the UK government as one of the 5 critical technologies for the UK. And as such, it's what you might call a technology that the UK is keen to pursue strategic advantage in. And by that, I mean harnessing the science and technology that underpins it purposefully to achieve defined outcomes in terms of security, prosperity, resilience, international influence, and of course, people and the environment. And in April, the UK government published the UK Wireless Infrastructure Strategy, which encompasses a 6G strategy. And it states that we want to ensure the UK is helping to set the agenda for 6G, and that setting a clear, coherent direction for 6G now reflects the government's commitment to building strategic advantage and to maintaining the UK's position as a global leader in science, research and innovation. So I'm going to come to you, Dimitra and David, for quick thoughts, but I just come to you, Malik, first, and maybe say, again, what's that international perspective on the strategy? How is that being perceived in the wider international community?
I think this is my personal opinion. It's a brilliant strategy and move. Although UK came late to the party, but I've seen in last 18 months the kind of initiatives that UK have launched has certainly put them in driver's seat. For example, as you said, UK has made telecoms as one of the top priorities, top 5 nation priorities. That's a brilliant move. That resulted into this DCIT and EPSRC funding for creation of research hubs. The beauty of the research hubs, I personally believe that it brings that system level research, bringing that multidisciplinary fields of communications, networking, computer, and AI researchers together to drive that system level research. That's something unique about it. At the same time, workforce development through CDT, Center for Doctoral Training. I think that's extremely important apart from research. The fourth one I noticed is that creation of the TIN, the Telecom Innovation Network, bringing all the key stakeholders, including industry, academia, and governments together. But last but not least is a GCOT. Recently, they announced GCOT, essentially to inspire international cooperation with US, Canada, Australia, and Japan. So I think in last 18 months, what I notice UK strategy is making tremendous progress launching these 5 major initiatives.
Thank you, Malik. So quite a positive perspective there. David, do you agree with that? Any other thoughts you'd like to share briefly on the strategy in the UK?
I just would link a little bit together from my previous comments. So firstly, 2 points. The first is that I think on the wireless side, I agree. I don't think a strategy in terms of how that then pulls into the core network is as well developed. And I think that's an oversight. And I think people are working towards adding that in the next phases. And I'm encouraged by, I'm very encouraged by that, but we need to follow through. Secondly, I think the issue is a lot of what Malik talked about, I'm sure Dimitra will talk about, there's a lot of ingredients there. I think the missing part is perhaps we're not clear enough about what's the proof of principle or the recipe that this is all going to go to. So we have a lot of collaboration around bits and pieces, a lot of small projects that are funded, hubs with small topics and so on. And I'd like to see us take more grand challenges. We are going to build X thing. And from that, we need the following ingredients to be developed to do so. And then the proof point is that we've deployed that in some way, which ultimately I think would drive scale.
Thank you, David. Interesting thoughts. Dimitra, do you want to build on those as well?
Yes. Just to comment on Malik's statement, which is absolutely right. And I agree that the UK came a little bit later than others naming 6G in the strategy, but we started earlier because before the wireless infrastructure strategy, we had the telecoms diversification strategy, which focused on open networks, and that's a key ingredient going for future telecoms. So there is a build-up from supply chain diversification, which have been seen, and quite rightly, I believe, quite key for the UK, then moving into wireless strategy with 6G. I'm delighted with this strategy. But I would agree also with David, we are making these interventions. This is a significant intervention on telecoms collectively, starting from 5G testbed and trial, the diversification, and then wireless strategy. And actually, I can see the impact. I can see the impact and how it actually supported research and commercialization over the last 6 or 7 years. My problem with this is not so much is the scale, but also the longevity. I mean, we live in our funding within spending review cycles. And when we are investing on research and innovation, it has to be longer term. It can't be everything falling off the cliff end of March 2025. Mm-hmm. And I think that is the big challenge we are facing now going forward.
Thank you, Dimitra. I can see all your colleagues nodding, which the audience can't see, so obviously resonating there. Right, I think we really have to try and get some of these great audience questions that are coming in. We have to we're going to bounce around a bit because there are many different topics, and I might try and squeeze some more of my own questions in again. But audience, please do keep your questions coming. So we've got Will Stewart asking you, Malik, to talk about the potential for free space optics.
Honestly, I'm not an expert at it. I would have to defer this to David or Dimitra.
So Malik, you were volunteered by Will, but if anyone else would like to come in on this, please feel free to.
So, Dimitra, would you like to just talk about the if part of the question is does optics have a play in terms of distribution, particularly in high density, metro type environments? Perhaps you could speak about that.
I mean, okay, it's passed to me. Free space optics is a key emerging technology. It is emerging for some time. When I think about free space optics and the impact that comes from the UK, I always think first of Li-Fi and one of other fellows, Harold Haas, that actually invented it. And it's a brilliant, absolutely brilliant technology, especially starting with indoors environments and now progressing very well for outdoors environment, making a very strong proposition for an access technology for 6G. Free space optics, we can start speaking about free space optics and optics in satellite links. So it is an important technology, and we are going to see more and more of this. In my community, when we are looking actually at future networks and future systems, we are looking how we can evolve to what we call multi-access. So when we are looking at 6G, 7G, we are not talking only about cellular and radio access networks, but actually start looking collective use of RF, extending the spectrum to terahertz. Malik mentioned this, but then extending the spectrum to optical wireless. And there we can see actually free optics and free space optics and optical wireless start integrating in mainstream future cellular systems.
Thank you, Dimitra. I'm glad someone was willing to take that hot potato. We're going to go now to Melanie Hardman's question, which is, do any of you see barriers that the future telecoms industry is facing before considering adoption of quantum technologies? What do they need to see, hear, do in order to consider it? Who'd like to have a go at this one? Dimitri, do you want to have another go?
In my team, my colleagues are doing a lot of work on quantum networks specifically. And when we are looking at quantum in systems, the first application we all know is QKD. So using quantum key distribution for security. And this is an application that is here and now. There are vendors that actually they provide solutions. I can think of Toshiba, I can think of Adva, and other vendors that they provide QKD solutions that they are actually being deployed in commercial networks. What's exciting is going forward, because when I look at systems going forward, I think for me, a key question is how classical traffic coexist with quantum traffic. I cannot see a future that we pull out all the infrastructure that we have at the moment, the internet infrastructure, to actually replace it with quantum-ready infrastructure. So how we can actually secure that coexistence. And then the exciting aspects come when we are looking at, Malik mentioned again, is not only communication pipes. We are moving more to cloud, and we are moving more, to software networks, and therefore computation is becoming more important. So how quantum computing would come within mainstream network architecture, how quantum cloud is going to look like. Some hyperscalers, they provide now quantum cloud services to play with. But from playing to actually seeing real system emerging where they're going to be converged quantum and classical system in the real sense, for me, that is the barrier, because that's exactly when we start making real propositions for commercial deployment at scale.
Thank you, Dimitra. That was great. Does anyone else want to come in?
Yeah, just a small few comments on that. So So firstly, I could be slightly parochial and talk about the benefits of hollow core fiber and lack of non-linearity, which is an example of a new technology that actually brings tools to the network and to designers and to people who are thinking about applications. But it's not in quantum. It's not the only one. In hollow core fiber, the signals don't get mixed up so much, to put it into lay speak. Okay, so potentially, but our current network is not built that way. It's not built with that type of technology. So this is another example I was speaking about how the new technology challenges come with the new applications. The whole technology component, the technology of all the components, is going to be a really big challenge in terms of the rollout of quantum. We're going to move to different wavelengths for the sources, how those sources are integrated, how those sources communicate, how they scale within the quantum computing environment, and how all of these different elements talk to each other is another huge challenge. So I think the pull-through need around quantum, whether that be in quantum compute or in distribution, I think that will happen. I think there's a lot of ingredients that are scalable, manufacturable, deployable in volume, and the changes that are going to be required in the network. All sort of has to happen in a holistic sense before the potential of quantum starts to move into mainstream.
Thank you very much, David. That was, again, really helpful. Now, we've been talking for over 40 minutes, and in the world of telecoms, it's very odd that we haven't talked much about standards. So I feel like for those people who are coming relatively fresh to this challenge, we should make sure that we just spend a minute or two on this. So Malik, can I come to you to just give us the quick introduction to why standards are so important in telecoms and the role that they play in particular in innovation in this area?
Absolutely, Hayaatun. In order to appreciate standards, we have to look back and see how we evolve. When we look at 2G networks, the 2G networks, there were multiple regional standards. Yeah. And then as a subscriber or user, you are tied with the provider and operator. Means your device and the telephone number is tied with the provider and operator. There's no way you could keep the device and phone number and switch between the provider or operators. So I call it as subscribers don't have the freedom to have universal access. Yeah. Now, fast forward to 5G. Now we can have global roaming where you can have universal access. Yeah. You can keep your device and telephone number, but switch between the operators and providers. So that is the essence of standards. The standards, having that global international standard has given such a freedom for subscribers and users like you and I to have that universal access, global roaming, the freedom to move between the operators and providers. So it's easy to say, but there's so much complexity behind that. In 5G, we are talking about more than 10,000 combination of frequency bands used around the world. And we are talking about a technology complexity that Dimitra and David mentioned. We're talking about multiple ecosystem players, all the way from academias, governments around the world who are looking at auctioning the spectrum, with different frequency bands, and industries, all the way from chipset, devices, infrastructure, telco, cloud providers, to application providers, to industrial sectors. So you have one of the most complex ecosystem in the industry. How do you bring them all together to work towards common specifications, to give that freedom to subscriber, to have that access to the information at any time from anywhere using any device? So that's the essence of having international standards. And I hope we'll continue to keep in current geopolitical environment as we move towards 6G.
Indeed. Thank you for that, Malik. I felt it wouldn't be a complete discussion of future telecoms without touching on standards. We've got quite a few questions. I'm going to have to try and encourage people to give quick answers so we get through a few of them. There's lots to cover. So Jonathan Lyle is asking about how new technologies and systems might offer improved resilience to threats to the network, whether natural or malign. Who'd like to pick that one up? David, you'd like to have a go?
I'm sorry, my internet, completely froze and I didn't hear the question.
Oh no.
How ironic is that?
It's a bit spookily ironic. Dimitra, would you like to have a go at that as well, David?
Actually, it may not be David's internet because I lost also half of the question.
Oh dear, well maybe it's mine. Sorry, this is embarrassing, isn't it? Okay, the question is, hopefully everyone will get it this time. Could you say a little bit about how new technologies and systems in future telecoms could offer us improved resilience to threats to the network?
Okay, so I think there's a big security aspect here, and I'm going to let Dimitra and Malik talk about what they do I talked earlier about layers, so I'll let them talk about the network layer and the services layer. At the physical layer, there is also still a threat, and what is happening is people are thinking about how can we actually make the physical layer more resilient to things like tapping and so on and so forth. And there are technologies that are emerging that will allow more resilience for that type of intrusive behavior. But I'll let my colleagues who are much more expertise on the software and networking platform side speak.
Malik, would you like to come in quickly?
Yes, let me give an example of AI. The thing is currently, the question is that how do new technologies and systems might improve the resiliency and security aspects. I think let's talk about the problem today in the real world networks. The problem in our real world networks is that there's lack of visibility monitoring what's happening on the networks. Yeah. At the same time, we are talking about speeds, gigabits per second, terabits per second speeds. So these networks are generating massive amount of operational data that a crap person cannot sit in front of a network manager and go through that. This network operation data is in the form of logs, alarms, and traps, and so on. So the idea is that how do we really apply AI to really crunch this data to analyze and act on any vulnerabilities? How can we make networks more cognitive and more resilient? So that's one aspect of AI that we are looking at.
Interesting. Thank you, Malik. I'm going to take a slightly different spin before I come to you, Dimitra, which is that actually when we think about resilience, we also need to think about the health of our skills base. So would you like to comment on how well you think we're doing in the UK in terms of fostering that skills base that we need to maximise the value that we capture here from future telecoms?
Yes, that's a very important question. When I started my career, there were two types of telecoms engineers. There were the engineers that they were RF engineers working on wireless, and there were engineers that they were working on wired, either in optical or packet networks. I was an engineer, and I still am at heart, an engineer working on fiber networks. Now, things have changed enormously. So our sector now, it actually requires many, many more diverse skills. Of course, we still need mainstream skills, but we talked a lot about software today, and we talked a lot about AI, and we talked a lot about security. And I think those are the skills. So we need software engineers more than hardware engineers. We actually need AI skills into our sector. We need cybersecurity expertise into our sector. And mainstream education at the moment does not provide these skills. Definitely personnel that they are in our industry at the moment, they haven't had these skills through their formal education, and probably they are having to acquire them over time on the job. So I think there is a need for a general rethink on how we educate telecom engineers in the future to be fit for purpose. And there is a lot of discussion. One of the issues that we have is that, for instance, if we are looking at AI graduates, is how we can start attracting them to do telecoms instead of doing creative media, for instance, or working in another sector altogether. And so in financial sector, for example, so we need skills that they are very competitive across many other sectors rather than engineering. So it's creating the skills and then actually acquiring the skills within our sector is a very big challenge.
Thank you, Dimitra. I mean, skills is a huge topic in its own right, so we're not going to have time to go into all the corners of it, but that's a really helpful overview. I'm going to give you a heads up. I think we'll give the final question in a minute to Will Stewart again, who had a question which was, what would your grand challenges be for future telecoms? What would you actually want us to be able to accomplish at that grand challenge scale? So whilst you're all thinking on that, I'm going to just ask Malik to answer Trevor Gill's question about, do we need a new G? Can anyone afford one? Is it time to just let 5G evolve gradually? What do you think, Malik?
I think Trevor has a point. It has to evolve gradually. Yeah. We have a number of problems to solve in our networking world. This is my personal reaction. We built so many networks, fixed, mobile, and satellite networks. It's a time to look at and see if we really want to nullify digital divide, how do we bring these networks together? How do we really have the absolute coverage anywhere across any community at any location? This is the time to think about how do we bring space, air, and ground integrated networks so that you have the same connectivity experience, whether you're in the flight, whether you're on the ship, whether you're on the ground at home. I think that's something we must look at.
Thank you, Malik. And I know, Dimitra, you feel strongly about this point around the accessibility of these technologies to all parts of society. Dimitra, would you like to add to Malik's comments?
Yes, I would like to answer to Trevor, actually, and in a different way. Trevor, I mean, the reason that we need 6G is because we haven't delivered 5G. And somebody told me we had 3G, but it was delivered with 4G. We dreamed about 5G. Hopefully, it's going to be delivered by 6G. So call this an evolution, but probably a new number would help, just to deliver the targets we all promised. So your question, Hayaatun, was about sustainability?
Well, I was wondering if you were going to take the angle that Malik mentioned around accessibility. So, we need to make sure that whatever network, whatever number we're up to, that we have equal access across society to it. I know it's something you feel
and this
is
about. Another reason why we need a new generation, because our language has changed now that we are talking about the new generation, and I don't put a number in front of it. And quite a lot of our sector start shifting the conversation for talking about performance, key performance indicators, to what we call key value indicators. So exactly, instead of asking the question, how many videos you download in a minute, we start asking the real question, what service availability we are providing, how sustainable is our network, how trusted it is, how inclusive it is. And if we take only this as an argument of moving on with evolution or evolution of our future networks, an important point to make. So actually thinking about not only technical, but socio-technical targets in our future innovation. And this is happening at the moment as key conversation when we talk about 6G.
Thank you very much, Dimitra. And I think, Malik, you want to come in again once more on this quickly?
One quick thing. Yeah, as we evolve 5G towards 6G, I think the adjacent technologies such as smart materials or metamaterials and the quantum computing and other technologies are going to enormously benefit our future networks or future wireless systems. Think about batteryless devices with metamaterials where you are able to power the sensors by translating ambient energy, So I think, to me, the adjacent technologies such as metamaterials or any computing or AI technologies are going to further strengthen the advancements of 5G towards 6G, apart from what Dimitra mentioned.
Thank you, Malik. That's an interesting addition. We're going to come to the grand challenge question. It's going to be a quick fire question, but David, did you want to add anything to this 5G question posed by Trevor?
No, let's free up the time for the next one.
Excellent. Well, maybe I'll start with you then. What would be your grand challenge for future telecoms?
So I think we do a really good job on certain testbed type configurations. Dimitra has some great testbeds in her facility, for example. But they're small scale. And as a result of that, we don't see innovation that drives into creating that. So my grand challenge would be, let's build the world's best link, should we call it that, north-south through the UK, highest capacity, lowest latency, with a lot of hooks on it, possibly in partnership, so that some of the capacity it's very expensive to do, so some of the capacity can go for true commercial use with partners. But then let's create a real world deployment that drives a meaningful volume of new technologies to be developed and deployed to show it works in the real world, in volume, that can then from that be scaled out. And if we did that, we could encompass all of the technologies we've talked about, whether it be in the physical layer, the security issues, build it so it can do QKD at the same time. Let's show lower latency. Let's show a higher capacity, better economics associated on each channel, new data formats, and so on and so on. And then it's an investment for the UK, where for the next round of technology, it can become the ultimate testbed.
Fantastic, David. Over to you, Malik. What would be your grand challenge? If you could unmute. Thank you. Yes.
Yes, there are a couple, but starting with the first one, how can we provide that seamless, consistent connectivity experience, whether you are in space, air, or ground? I think that's the essence of our focus as communications engineers. Yeah, that's the first one. The second one is that as we see the convergence of connectivity, compute, and AI together with sensing, yeah, how this convergence is going to evolve over the next 10 years.
Brilliant, nice and concise. Thank you, Malik. And what about you, Dimitra? What would be your grand challenge?
Right. As my two co-panelists took my first two choices, I'll go with the third one, which I think is a very important one as well. Communication networks, ICT infrastructure, and network applications consume increasingly a lot of energy. And we are in a period of climate change, or climate emergency, let's say. So my grand challenge is how we can drive energy consumption of our network infrastructure as low as possible, and how then we use these infrastructures that we now create to actually contribute to net zero targets. So that is my grand challenge.
Wonderful. What a brilliant set of grand challenges. Great question, Will. Thank you very much. So it now, unfortunately, is time to end this really stimulating discussion. I hope you have enjoyed it as much as I have. I've learned so much from our brilliant panel. It's a classic example of an immensely powerful set of technologies that make up this socio-technical system. Digital transformation driven by connectivity is something we've all become a lot more familiar with as a result of the pandemic changes. And I think what we've heard is that it's only just beginning, and the potential for further transformation is enormous, but we want that to be resilient, inclusive, fair, and accessible to all. So thank you so much to our brilliant panelists and to all of you for your insightful questions. If this conversation has sparked your interest or you have further comments about today's event, please do respond to the survey. We've posted into the chat, and I think you'll also get an email afterwards, because your feedback helps us to shape and improve our events. Stay tuned for further critical conversations on LinkedIn. You can follow us on our LinkedIn page, and the next event will be on Tuesday, the 30th of January at 6 p.m. on the final technology mentioned in the strategy, which is artificial intelligence. So you can also catch up on the past critical conversations via the link in the chat. Thank you so much for joining us, and have a very good evening, everybody. Goodbye.